We divide machine learning into two categories, supervised and unsupervised learning. And there is also reinforcement learning, but we will go there later. Basically, if we have labeled data, we use supervised learning. In supervised learning, we provide input data as well as correct output data to machine learning model. Classification and regression are most used supervised learning techniques, and most neural networks are also supervised. Classification algorithms are used when the output variable is categorical. It looks for a collection of categories to find the best match for a given input, and groups objects into preset categories or subpopulations. Logistic regression, naive bayes, k-nearest neighbors, decision trees, support vector machines are top classification algorithms. A population is the entire group that you want to draw conclusions about. A sample is the specific group that you will collect data from. Each piece of observed data is also called a sample. A measurable piece of data that can be used for analysis is called a feature. It's also a column of the data in your input set. The goal of regression model is to build a mathematical equation that defines y as a function of the x variables. Regression algorithms predict the output values based on input features from the data fed into the system. Simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression are top regression types. There are differences between regression and classification models. In regression, the output variable must be of continuous nature. It can be a real number, and in classification, it must be a discrete value. If we are trying to predict the temperature, it's a regression model, but if we are trying to predict if it will be a rainy day or a sunny day, it's a classification problem. And when our samples don't come with labels, we use unsupervised learning. Most common types are clustering and dimensionality reduction. Normally, neural networks are in supervised learning category, but autoencoders are in unsupervised learning category. Clustering is like classification, but we don't have the labels. You put the population into a number of groups such that similar items are in the same group. Dimensionality reduction refers to the techniques for reducing the number of input variables in training data. We might have the same data in different formats. For example, if it's the temperature data, one column might store it in Celsius and other in Fahrenheit. We can remove one of them. Or we might have a three-dimensional data which could be converted to two-dimensional data.